just seen some of the slides, and so we're really really happy to hear what we have to say the next 75 minutes. If you have any questions, put them in the chat, and I will put them to Ed. Otherwise, there will be questions at the end of the session. So, without further ado, over to you, Ed.
Okay, thanks very much, Ian. And I have one favor to ask of you, Ian. I will start sharing the charts. If you could just let me know that you can see them, once I start doing that.
Okay.
Um, yeah, and to Mainstream, thank you very much for the invitation and opportunity to come speak with you all again. Um, like was said, I've had the opportunity to speak in South Africa and also in Melbourne and in Perth over the years. So I've really appreciated those opportunities and try to bring some of the story of what we do in human spaceflight operations and human spaceflight in general um, to you. And when it was very first brought to me to consider coming and talking about these topics, it didn't um, I needed to learn more about what Mainstream was focused on and what the industries involved were about. But it really quickly became obvious that, of course, they're very dissimilar in some ways, but in a lot of ways, it's very similar. The risks that are involved, the complexity, the nature of operations, and long distance operations with critical infrastructure, all those sorts of things. And more is very much common. So hopefully, through this talk, I can, of course, explain what we do in human spaceflight. And these days, of course, it's not just NASA, not just the United States doing it. It's an international, worldwide endeavor. So, Australia and New Zealand and UK and so many other countries are directly involved in this effort. So it's my honor to share with you what we're doing with humans in space. But then, of course, it's a different way to look at some of the same challenges that are being faced in all the industries that y'all work in. So hopefully this gives you maybe a different perspective on tackling some of the same problems you face, or maybe it reinforces what you're already doing. Um, but hopefully I can bring some of that to you. So and then the backdrop behind me, just kind of get out of the way for a second. This is obviously a graphic representation of the lunar space station that NASA and its international partners and corporate partners are working to put into orbit around the moon in the next few years. And my job for the last 24 years has been working in mission control, and that's where we're going to spend most of our time today talking about. But I just recently transitioned out of mission control to work in what we call the Gateway program, and that's what this space station is called. It's the Lunar Gateway. And my job is to help make sure the first two pieces of that successfully launch, spend a year getting out to the moon, and then getting into lunar orbit to support a whole bunch of things that we'll cover here in a couple of charts. But that's just a little bit of my background and the purpose here. I'll get into a little bit more of that as we walk through the talk. And I'm going to go ahead and try to properly share these charts with you, and we'll go from there. So bear with me just 1 second, please.
All good, Ed.
Excellent. Thank you. Okay, so let's go on. So before we get into all the technical conversations and lessons learned and case studies and things like that, I thought it would be a useful experience for everybody to be able to just take a couple minutes and see what your planet looks like from the perspective of the International Space Station. So if this works right, you're going to see, I think it's a 3 or 4 minute video of a bunch of different clips of time-lapse photography that the astronauts have taken over the years of the planet. And things I like to point out to people as they're watching it is, besides it's by itself, it's really spectacular. But you're going to see a lot of the aurora. Most of that is actually the Aurora Australis because of the southern aurora is usually a lot more vibrant and visible to the space station than the northern lights. So for all of you south of the equator, you get a better experience than we do up here up north. But then also the weather phenomena and all the flashes and things you'll see, the bright lights, that's going to be lightning. And just how massive these weather systems are and how really interconnected our planet is something else to point out. So I'm going to go ahead and start the video, and we'll just hopefully you all hear the sound and everything comes through okay. It's always fun to well, it's more than fun. It's just amazing to be able to start a conversation off by just taking some time to look at our planet. So hopefully that came through okay for y'all. But and I guess I'll also add, so I talked with Ian, and I'm gonna provide a PDF of these charts if anybody wants to look at them. But there on one of the slides, it'll have a link to that video and then some other videos as well. If people are interested, there are actually a good number of these time-lapse type videos out there as well. But so I don't know if we have any Swifties amongst us, but Taylor Swift has done a very good job of bringing the term era back into pulp culture. And I thought, maybe it'll be good to start talking by talking about the eras of spaceflight and human spaceflight. So first, reflecting back, where did we get started? Call it our courageous exploration era. Um, in the very late 50s, the 60s, 70s, and even up into the 80s, you had the first ever satellite orbiting Earth, the first human, the first American in space. And then we started learning how a little bit to operate in space with the sole focus really of sending people to the moon with the Apollo program. Once we, had boots on the moon and brought back some rocks, we started thinking about living in space for longer durations. So both the Soviet Union and the United States had their space stations. And then, again, back in the 70s, we're talking about international cooperation in space and making it a peaceful endeavor. So we had the Apollo-Soyuz test project. And then again, at the end of this era, we were talking about starting to exploit space with respect to human exploration, and you started to see the space shuttle, the Soviet and Russian space station Mir, and then the Russians have their regular crew transportation capsule capability. So then these pictures are just kind of representative of some of that. And then in the 90s up to today and the current decade, we kind of moved into what I'd call the space-based economy era. So we've learned how to master our presence in low Earth orbit and now really into the commercial exploitation of the environment of low Earth orbit. And so you've got things like the International Space Station that first launched in 1998 with the very first pieces. Humans started living there in November of 2000. So it's been just over 24 years now that humans, at least 2 human beings, have been living off planet continuously since November of 2000. If you're probably aware, there's another space station in orbit right now. It's the Chinese space station, and they've got 3 of their astronauts regularly on board doing their own investigations in science and research. And then there's this commercial space industry that I don't know if we still call it developing. I guess it is, but it's really becoming a common phenomenon, a common thing that's happening, especially with SpaceX and their Dragon capsule and their Falcon rockets. But you've also got Boeing and their Starliner, Virgin Galactic, Blue Origin, and then commercial space stations are really on the cusp of becoming a reality as well. Well, that's everything that's going on right now. But then we're looking to our future as well. So the next era that's coming up, and it's really just already had its initial beginnings. Today is actually the 10th anniversary of the first launch of the Orion capsule. We call it Exploration Flight Test 1, EFT-1, but so that's the capsule that's going to be used to send astronauts back to the moon, and then also to visit the Lunar Gateway space station that I was talking about, with an initial vision to have people walking on the moon and coming home via the gateway. But longer term vision is a longer term presence on the moon, eventually putting habitats there, long term stays, multi-month, and then even leading up to a continuous human presence on the surface, doing research and exploration there. And that's helping us lead towards the next era after that, which is really just our future. And our future goal is humans on Mars. And then after that, it's up to your imagination with where humans want to go. But that's everything that right now the human spaceflight endeavor is really focused on the eventual human footprints and then presence on Mars. And just to kind of give you an idea of why why Moon then Mars, or um, what's up with Mars. So just it's kind of fun information for you. So Earth is about 225 million kilometers from Mars, compared to 384,000 kilometers from the Moon. So it's 585 times further from Earth um, to go to Mars than it is to go to the Moon. So that's this backdrop picture. You probably already figured it out. The little dot in the sky is Earth from the vantage point of Mars and the Mars Curiosity rover looking at home. So you are really, really far away um, when you're on Mars. It's about a 6 to 9 month trip to get there, about 6 to 9 months to come back. And then staying on the surface, when we send people there for the very first time, you can either stay for about a week or you stay for about a year. There's really no in between for those two options. So given all the distances and the risk associated with that, we want to leverage as much as we can from what we're learning on sending people to the Moon first, where the Moon's only a 3 to 6 day journey back to Earth versus multiple months. And then people want to know, and rightly so, why would we even want to go there? And there's the altruistic answer. I'm an altruistic guy. I love doing this because I just want to send people out to explore. I grew up with Star Trek, and I just love it for that reason alone. And I think it's understandable by everybody to go explore and see what's out there. But sometimes it's not enough to justify why we do these things. And so really the return on investment comes with basically an understanding of what is going to happen to humans and the Earth, and what has happened out in the solar system to other planets and planetoids that we can learn from, kind of learn more about our own planet, and then what we can do to maybe safeguard our wonderful oasis in the universe, so it doesn't become a desolate place like like Mars or the Moon. And if you're curious about more, there's a link there to start answer your questions a little bit more about humans on Mars and why and how and all those good things. So those are the, if you will, eras or paradigms, is maybe the more old-fashioned version of saying the same thing, that we've been through in since the late 50s with humans and human spaceflight. And of course, there have been transitions between each of those time periods where we are changing our focus and our mission and the way the missions are defined. And so everybody I know is very familiar with the paradigm shift as a conversation topic. And of course, if you do them well, you recognize the need for them early, and you prepare for them in advance, and you adapt before they actually have to come about. But sometimes you don't get the choice. Sometimes they get forced upon you. And that happened to us most recently with the loss of the Space Shuttle Columbia. And the space station was assembled using the space shuttle. And there were other countries, they did their own launches. So there was some heavy lifting by them, of course, but all the US components were brought up by the space shuttle. The crews were rotated by the space shuttle. And so we were very space shuttle dependent. And so humans started living on the space station in the year 2000. And then Columbia was lost in 2003. And so it was, space station was still very young, and suddenly our kind of simple, easy, frequent access to space was lost. Our good friends and family members were lost. And there was a 2 year down period while we were trying to figure out how to return the space shuttle to flight. And that made the space station suddenly go from space shuttle dependent to space shuttle independent. And so that's a example of a paradigm that was shifted under us, and we had no choice but to adapt. And even then, It was made more difficult. There were people on the space station when that happened, so you couldn't do a stand down for a number of months to figure it out. We had to figure it out as we went, um, and and it's because just generically how we've set up our operational approach that we were able to work through that and learn and adapt pretty quickly to that shift that happened underneath us. And across all of this, and one of the big points I'll be making today is that you've got to decide in advance what elements of your enterprise are going to remain fixed when you change paradigms or when they get changed on you, and then what things are negotiable or easily recognizable that you'll need to adapt. So let's talk a little bit about mission control. That's where I've been working for the last 25 years minus 2 months. And this is, as far as the space agency goes, one of our premier leadership laboratories. And this is where we take college graduates, kids in their early 20s, make them responsible in part for a $150 billion spaceship, 250 miles above the Earth, going 25,000 kilometers per hour with 7 people on board, and tell them that any action they take could have ultimate consequences. And then we train them up on how to be the leaders we need them to be the operators we need them to be, and to be the safeguard for the crew and for the spacecraft. And through that process, then we're able to hopefully retain them for a while so they continue to do excellent work, but then they take what they've learned and adapt it to other areas in the field, other parts of the agency, or even outside of the agency. And like I mentioned, we spend a lot of time focusing on what has to stay the same and what can change. So mission control, if you have an industry that has a control room for an operation that's not in the same room, I'm sure this looks very similar to what you're used to working with. The view screens might be different. You might have more, we might have more. Computer screens, various displays for looking at telemetry, different consoles that are responsible for different parts of the mission. Some of the things that people are responsible for are the actual systems, power, thermal, life support, and then the other people are responsible for kind of some of the other things that have to happen. We have humans on the space station, so we have to be able to talk to them. So we have a person that does that. They have a lot of portable equipment, and so we need to know where to plug in all the battery chargers and laptops and things like that. So we have people that are responsible for the plug-in plan. Storage on the space station is at a premium, and we have way more stuff on board than we know what to do with, accumulated over the last 25 years. So we have people that are in charge of our inventory and where things are stored. And then all of those people on the console are responsible for their thing, but of course not in a vacuum. They're paying attention to what's happening across the room, across the mission, and then reporting all of that, working together as a team to talk to the flight director. And the flight director is the leader of the team and the highest authority in the room. And so that's what my job was since 2009. I was one of the NASA flight directors, actually the 78th flight director in NASA's history, and they're up to 108, I think, not to date myself, make myself too old. But so there's the flight directors have this ultimate authority and responsibility for the safety and lives of the crew and the spacecraft. But we even then we don't work in a vacuum, right? It's not our mission. We're just operating the mission on behalf of the mission owners or the program. For us, it's NASA, the government agency, versus a private company, but it's basically the same responsibility. And then, of course, we have access to offline technical support. Sometimes they're in the building, sometimes they're spread around the world, depending on what it is that we need help with. So the way that we get ourselves ready to go execute a mission is what we call plan, train, fly. And you can see the boxes here, kind of outlining all the different components. The first thing all the way on the left is the owners need to tell us what they want us to do. And then they don't just buy us as a service where we just blindly go execute what they tell us to do. Instead, we are involved in development of the mission with them. They will give us the mission requirements, and then we will work to figure out how to go do it. And you can see the long list there, the design, analysis, have we done it before? Are new things needed? How are we going to train the flight controllers? How are we going to train the crew? And in general, can it be done? And usually the answer is no. Usually they want something that's just not initially achievable without something else. And so then we have this purple line going back to the program. And we go back and forth. If you want to do this, these are some other things that you need to be able to do. These are things the spacecraft needs to be able to do, because we're also looking at things like safety and resiliency of the vehicle. And once we get that hammered out, of course, training is involved, getting everything ready to go. And this is where we start also preparing for what do we do when things go wrong. And it's not just when things go wrong at the first level. I think that's all pretty simple and it's pretty standard. If a switch fails or a system fails, how do you respond when that happens? But we spend most of our time focusing on what happens when a second failure occurs. So we have this thing called next worst case failure, or next worst failure preparation, where we look at critical things that might break, and then what happens if another critical thing happens while that first thing is already broken. And that, of course, gets not only complicated, but it also gets pretty unwieldy in all the different permutations that could happen. And it also gets really expensive. And then that's where the tension, the healthy tension lies, because we'll want to protect all of those things. But of course, in your design and in your risk assessment, you've made sure that those things really shouldn't ever happen. And so then there's this risk trade that happens with what do you protect for? How much money do you spend? Do you build hardware? Do you just create contingency plans? But you finalize all of that. And then finally we go and fly. And fly is really it's the smallest box because by that time you've done a lot of the hard work, and then you're just making sure the crew and the vehicle are safe. And because you've done the hard work in advance, this part of flying, even though you're going to see a lot of challenges and difficulties, it's actually something that you've prepared a long time for and you're ready to go implement. So how do we do it? We try our best to be what's now being called a mission critical team, but we try to do the best we possibly can at being a high performing organization and a high reliability organization. So I want to talk briefly about what those things are. So high performing organization has 5 common traits, and in italics for each of these is the definition. So leadership, being aligned and effective, not just at the top, but deep into the organization. And so in mission control, we do that through a chain of command that is, like I said, in mission control Houston. So in our control room, the flight director's at the top of the chain of command, but it's also between our control centers. International Space Station has 5 mission controls supporting it 24/7, and they have 5 flight directors around the world doing basically the same thing for the part of the station that they're focused on. But you can't have 5 cooks in the kitchen and have an effective chain of command. So in Houston, the flight director there is also the lead flight director for the whole International Space Station. So the top of that chain of command is a singular individual, and everybody has signed off on that and respects that. And even if my boss were to come in and tell me to do something, or the president of the United States, if I say no, then it doesn't happen. And that's where it stops. Of course, if the president tells me to do something and I say no when I go out in the hallway, there might be a different conversation. But at least in the control room, the chain of command stops at the flight director. And so we've got that unambiguous chain of command. And again, we're pushing leadership down as deep into the trenches as we can. This concept of lead your leader, I want the flight director to be the dumbest person in the room because we have experts in the room for each area, and we expect them to step up and provide their assessment and their input. And that frees the flight director up from having to know the deepest detail of every system and is able to do things like risk assessment and mission priority decisions. And of course, the design of mission control and how we do things needs to be lean and reflect our strategic focus. Sorry, and so we write all of that down in all of our different processes and flows and certification guides, and then we review them regularly to make sure that we maintain aligned with our goals. Um, People are always very important, and also our organization. So we need to make sure that we are bringing the people on board that we need and that we're able to retain them. So we do a lot of selective recruiting, as you could imagine. We do a boot camp right when they first come in to make sure that everybody's aligned with our culture and our foundations, and then put them through a documented training flow with pass-fail criteria. And unfortunately, some people are just not cut out for this business. And so we don't just cut them loose, usually. These are already very smart, talented people when they come on board. And so we usually find roles for them to continue to support, but maybe just not in a mission control environment. Change management and culture are the other two elements of a high-performing organization. So we've got to be able to sustain large-scale change and anticipate and adapt to it, which is really the whole focus of this conversation. And so there are things that we have established as non-negotiable no matter what we're doing, and that's our foundations, our focus on that next worst failure, and our number one priority always being the safety of the crew. But how we do it is always negotiable. And then we are always focused on our culture. I mentioned our boot camp, but we have all of these other documents, our manifesto, stone tablets, things that have evolved over time to really document our culture, our expectations of our employees, and the leadership expectations that we have. So I want to jump into a quick case study, but to do that, I need to maybe tell you a little bit more about the International Space Station. So just a quick graphic. So Space Station is about the size of a soccer pitch or a football pitch, from end zone to end zone, or goal to goal is the solar arrays, and nose to tail would be sideline to sideline. It weighs about 420,000 kilos. Cubic meter wise, it's the size of a pretty good house. Right now, we can generate about 240 kilowatts max, but then on average, we're doing about 90. So that kind of gives you an idea of how much margin we try to maintain with our power system. And then we're orbiting, like I said, about 415 kilometers, going about 28,000 kph, which that number is a bit ridiculous to understand. So think about it this way: every second, they're going about 8 kilometers, or 5 miles every second. So they're moving at a really fast pace, and it takes about an hour and a half to go around the Earth once. So they see about 16 sunrises, 16 sunsets every day. That's what your Earth orbiting city block in space looks like. So that's and I guess let me just go back to that real quick to help. So you see how the space station in the center has got these cylindrical modules. Those are the habitable modules. So all the people live inside those cylinders, and so the truss structure actually makes up the vast amount of the size of the space station to support the big solar arrays. And the central core there of those cylindrical modules will be a reference from where the video that I'm going to show you in a second is taken from. So just a brief example from my personal history of where the high-performing organization part came into play. It was dated now, over 10 years ago, so maybe I need to find a new example, but there's a Japanese cargo vehicle called the H2 transfer vehicle, or the HTV, and I was the lead flight director for number 4 that was going to come up in August of 2013. And they came up once a year. So number 3 was there in the summer of 2012. It had performed its mission. It did great. I was really happy on how things were going because it really meant I didn't have anything to worry about for number 4. Because so usually you've got lessons learned and things you have to fix for yours if it's the next one. Right up until the very last day when so this vehicle is attached to the space station through a berthing system, and then the robot arm is attached to it, and the astronauts will actually move the cargo vehicle down below the space station, so down below those habitable modules in the center line. And then when we tell them the timing is right, they pull a trigger, and then back the arm away from the cargo vehicle, and then the cargo vehicle is about 10 meters away from the space station, and it drifts further away, and then eventually goes on its own way and burns up in the atmosphere. That's what's supposed to happen, but that's not what actually happened. In the case of HTB-3, it actually got stuck on the robot arm, which caused it to get pulled up towards the space station. So I'm going to show you a short clip. It has a little bit of audio in it. It's the astronauts and the ground talking. Some of it's hard to understand. I'll try to talk over what they're doing, but just want to kind of show you what's going on. And for size-wise, this cargo vehicle weighs about 20 tons compared to the space station that was 420,000 kilos. So both of those are pretty massive vehicles going 28,000 kph. So this is the view from the end of the robot arm looking at the cargo vehicle, the docking target, or the berthing target on the cargo vehicle. They've just released it. They pulled the arm away. And if you've watched this video enough, you can see that it very much right away drifted a little bit up. And then you can see it was bouncing around as the arm was pulling away. And that's going to kind of be the source of our problem. But the arm is actually moving backwards right now. The cargo vehicle is supposed to be stationary. This is what the cargo vehicle is supposed to be doing now. It's supposed to be drifting down and then starting to move away from the space station. So right now it's doing what we think is the right thing. And then they've just stopped moving the arm.
Houston Station on 2, HTV retreat is commanded and the PT timer has been started. Right now we have a PT of 53, 54, 55, 56.
So the astronauts on board are saying
copies. Nice job.
that the arm is done moving, and they told the cargo vehicle to go away from the space station. But if you look at the video, pretty obvious that it seems like it's getting closer, which is kind of going in the wrong direction. Right now, it's about 4 meters away from the space station's robotic arm. Fast forward a little bit, you can see that it's gotten still a little bit closer, but now it's finally going down like we had intended. So we kind of thought we were maybe out of the woods.
Station Houston, for a status, we see an opening rate of 0.5 down here. We'd like to know what you see up there and also distance from the arm.
So we're remote, right? We're not there to see what's going on. So we're asking the operators on hand to look out the window and tell us what they can see.
Okay, the range rate on the nav is about 0.011, and the distance from the arm is like maybe 2 meters.
Copy.
Astronaut's saying that it's only about 2 meters away from the arm. It should be 4 or 5 meters away, and it should be further down away from the arm by now. And the cargo vehicle's had enough. It hit its safety barriers, and it is taken off like a bat out of heck. Here's another view looking from one of the truss cameras down at the cargo vehicle, just to show you what it looked like when it fired its 4 big main engines there on the right side of it, on the back of it, to get it out of there. This was actually, it's safe. It was designed to be safe, but it's very close to the space station. Ended up departing at about 1.3 meters per second instead of like the expected 0.1 meters per second. So the risk for collision was per the analysis was not a risk, but you never want to see something taken off like that from your big city block in space. It's, as much as we enjoy Star Wars and jump into light speed real quick, you just don't want that happening in real life. So we almost made it to a safe and happy and uneventful HTV-3 mission, but it didn't happen. My job immediately became not to let that happen again, but we were launching in 9 months for the mission I was in charge of, and so we were not allowed to change anything with the design. So the crew was going to launch in about 4 months, and we had 9 months to figure out how to fly basically that same mission without making anything other than operational changes. And to make things more complicated, you've got the space station program based in Houston. You've got engineering spread across Houston, Canada, and Japan. My flight operations team here, the robotics operation team in Canada, and then in Japan, you actually have 2 different control teams in Japan that all had to work together to come together to make this all work. And we were able to, in about 3 months, we were able to determine what had happened, why it had happened, replicate it in the analysis tools, and then come up with an operational scenario that we could train the crew on. And that all did happen successfully, largely because of that high-performing organizational aspect that we really try to instill, not just in mission control, but across all of the elements of the space station program. And of course, one of the options that you can look at when you're doing something in any operational thing is you can choose to do nothing. And that's actually what we did. And that was the ultimate solution. So I described the scenario when the astronauts would actually move the robot arm away from the cargo vehicle. And that actually is doing counter work to what the laws of physics are trying to do. And the laws of physics are already trying to pull the cargo vehicle out of the grapple fixture, the arm. And we were kind of messing that up by moving the arm at the same time. So what we decided to do was to release the cargo vehicle, but then leave the arm exactly where it was and let physics do its thing. So we did that. It worked fine, drifted away just like it's supposed to. And then the operation was successful. And we did that for all the rest of the Japanese cargo vehicle missions. So another little tip is that sometimes the easiest and best thing to do is just do nothing. So that's high performing organizations. The other aspect, though, is high reliability. So we need to be able to do things, do things well, do them quickly, be really on top of our game. But at the same time, you need to do it safely and reliably. And so that's this other aspect that we need to talk about. And it's really split up into 2 different focus points. One of them is trying to prevent things from happening. And so you've got a preoccupation with failure, your reluctance to simplify things, and then thinking about operations in every step of your development and design. How is what decision you're making now going to affect the operations of the mission or of the project? But then you also have to be able to react to something once it's happened. How do you contain it? And so that talks about your resilience and where your expertise lies. So again, let me give you a case study in my experience base. This time doing having to do with spacewalks and how we worked through our reliability. And if you can see the graphic moving, you can see the snow is going from bottom to top. And that's because one day in May of 2013, the crew called down and asked if it should be snowing outside the space station. And a mystified Mission Control was thinking, no, it's not predicted to snow today or any day because it doesn't really snow in space. Why do you ask? And so they reported they were seeing what looked like snowflakes coming out of one of the elements of the truss. And we've known for a long time that one of our ammonia system loops on the truss that's used to cool everything, in this case with the battery systems on the space station, had been leaking, but it was really slow. And we had a plan to eventually to take care of it, but it was not something that needed a lot of quick action. Turned out that a very, very slow leak became basically a rapid rupture over the course of just a few hours. And so it immediately became something we needed to take care of right away. And there were a lot of circumstances that we'll talk about, but essentially we were told to go do a contingency spacewalk in less than 2 days. So really in about 36 hours. And unlike TV and movies, you don't just throw on a spacesuit and run outside and fix things. Wish you could do that. But normally it takes us about a year to prepare for and to train for any spacewalk. So when you're watching, I know all of you watch NASA TV and you love it and it's your #1 go-to channel. So when you watch us doing, we call them EVAs because we have to have acronyms, but when you see them doing spacewalks, it's probably been at least a year, maybe 18 months that things have been in work to plan those to get them done correctly. But getting back to the next worst failure conversations, we do have critical things that we know we need to go out and fix pretty quickly. And some of those things are outside. And so we have developed a plan. We've developed things enough to where we only need 9 days to go outside to do a critical contingency spacewalk. So if something on that list fails, then we need about 9 days and we can get people outside to go fix it. So this thing that is leaking is not on that list. And 9 days is not 36 hours. But the reason they wanted to do it is because it was still leaking. And so they wanted to put people outside to go watch the leak so they could actually figure out where it's leaking from. Because once the ammonia's gone, you really don't have a clue where the leak's coming from. And we had 3 crew members were coming home in 5 days, and they need those last couple of days to really focus on being ready to come home. So if we're going to do a spacewalk, it had to be, if it didn't happen in the next 36 hours, it would probably be several weeks before we could get everything set up to send people outside. So that was what the program needed us to do. And we were successful in figuring out what the leak was and repairing it. And we did it by going outside in 36 hours. And so I just described to you all the things that we normally do to get ready to go do a spacewalk. And I tell you that we don't have anything in place to do it in less than 2 days, but we did it anyway. And so it definitely begs the question of, should we have killed people? Should people have died? Should there have been an accident? And then if you read studies and different theories on this type of thing, the answer should be yes. So doing a spacewalk is the most dangerous thing we do in space. Launching people is by far the most dangerous in general, and then bringing them back home through the atmosphere is second. But when you're actually in space, doing a spacewalk is the most dangerous thing out there. And you have these different models that talk about the more you compress your schedule, the more you reduce resources, the more you kind of skip over or circumvent your documented processes, you are more likely to make errors. And of course, everything I described, we were certainly rushed. And then the drift into failure. So basically, when you've got this big stovepiped organization, you are likely to drift into failure because all of your silos are making their own decisions that make sense to them, and they don't necessarily do well in talking with each other. And how do you hand off communications? And so when you try and do that in a very rushed environment, you're likely to make mistakes. And of course, I just spent, I don't know how many minutes describing how matrixed and stovepiped and separate we are, international partners and all these different consoles and everything. So clearly, we have a lot of teams working a whole lot of different things, transferring information back and forth. And so these two areas are saying that there should have been an issue, but yet somehow we were successful. So why were we successful? And the reason for that is because we have this high reliability organization approach to how we do business all the time. So it's not something we bring up when we get into a bad day scenario. It's just how we do things all the time. We're always mindful. We're always aware. We're always thinking about what's going on in our circumstances, our processes, and our culture. Which again, those are the 5 components of an HRO. So talk a little bit about our circumstances. The spacewalk, the EVA that we did to fix this problem was number 21. So I was the lead flight director for number 18 and number 19. Number 18 did not go very well, and it's a totally different problem. And someday maybe you'll get to hear me talk about using a toothbrush to fix the space station. But that was number 19, used the toothbrush to fix the problem that my team and I helped create on number 18. So those two happened. I was the lead for both of those. And then number 20 happened in November of 2012, so about 6 months before this ammonia leak happened. And that one was like a normal spacewalk, but it was out at the work site or right next to the work site where the problem existed. And it was manipulating ammonia system quick disconnects and ammonia fluid lines. And so we had just recent experience in that type of work outside on a spacewalk. And having done these 3 spacewalks in short proximity to each other, a lot of the flight controllers had worked together and had worked on these recent things. So when we picked the teams to do number 21, we picked from these teams of people so that they knew each other, and they had recent experience. And the circumstances were, and I still find this hard to believe, the 2 astronauts that we sent outside had been outside together on a space shuttle mission, STS-127, and part of the job that they had on that spacewalk was to go out and work at this exact site where we had the leaking ammonia we needed to go fix. So, and then the spacesuits they were going to wear, the day before this happened, they had just finished reconfiguring the spacesuits to fit those 2 astronauts. And so we didn't have to readjust the spacesuits that had just been done. We didn't have to tell the astronauts how step by step to get out to the work site because they worked together previously and they knew the work site already from a couple of years ago. So we could tell them, you need to go out to this place. And they said, done, no more training. We know how to do that. And then because, like I said, the previous 3 spacewalks, everybody in the whole enterprise had a lot of experience already with the technical details. So we'll talk about our processes. So matrix management, sometimes it gets a bad rap. Sometimes everybody loves it. So it can be a bad thing, except when it's a really good thing. And so this thoroughness trade-off model says that in order to avoid getting into trouble when you're making quick circumventing processes and making quick decisions, you need to have a whole bunch of different mental models in play and available. But then you also need to have a big picture, and so that you can take care of the whole siloing problem and make sure that communication is happening across all your silos. And so we actually use matrixing to manage both of those things and to institutionalize them in our operations environment. And so the way we do that is that first we expect all of our flight controllers to be leaders. And so I, as the lead flight director, don't have to go lead every single meeting and every single team. They understand their assignment and they know how to get that done. and they do it very well. They are also sending people to different meetings as they are happening. So they're not staying just solely within their silo. They know they need to go be present. So when the space walking team is developing some plans, the power and the thermal teams will send people to participate in that to make sure that what's needed is what's actually made into the plan. And then there's a lot of second guessing and double checking and making sure that that's not what I thought. I thought we were doing something different. I thought we did something differently last time. Everybody's free to and expected to speak up. And all of that work is happening at a level that's say below the program managers and the flight directors. I hesitate because I don't want to make it sound like, I went home, I slept for 3 days, came back, showed up and put on a tie, not really involved. And that's not at all the case. Instead, what we're putting our focus on is that big cross silo, big picture. We had regular meetings getting ready for this, but not too many meetings because then nobody gets any work done. To just to make sure that what are the priorities from the program? Have you considered these things? What do we do in this scenario? And just to make sure that all of the cross silo parts are being discussed. And another big piece of this too is that cultural piece. So one of our tenets in our culture is that it's okay to be wrong. The key, the buzz phrase is that failure is not an option. And a lot of times that's true, but not all the time. But not being allowed to fail doesn't mean you're not allowed to be wrong. And so we expect that our experts could be mistaken. And we also expect that the interns might have the best idea. And so we enable the interns to speak up, and we enable it so that the experts are open to being questioned about the things that they're experts in, so that we all have a good, thorough understanding and agreement. Everybody is involved, from the intern all the way up to the manager. And that's where the snacks come in, right? You got to feed the troops. And so we make the bosses go do the food runs and make sure that everybody's stress is as leveled out as they can be. And like I said, I would give out assignments and I expect them to go do the work and bring back the answers. And so I'm not micromanaging them. And the squeaky wheel thing, like I said, we expect people to speak up and ask questions. And sometimes it results in reworking things that didn't need to be. And that's just okay. And you have to accept that and be willing for that to happen, because sometimes it's also going to catch something and catch a mistake. And since it is the most dangerous thing we do, we want to catch all those mistakes. And finally, there's our culture. Crew safety is #1 priority. And I tell this every time we do a spacewalk, our #1 goal is to get the crew back inside safely and healthy. And if that means we don't do the spacewalk, no matter how bad the problem is, it's not as more important than the lives of the crew. So there's clear expectations on the priorities in that respect. And like I said, we were successful. We went from me getting a phone call of, hey, you need to come to work because your meeting is going to start in an hour for the spacewalk that you're going to do in 36. And then me saying, what's going on? And then getting out the door, we were able to get the task accomplished. But that doesn't mean that we can do it again and we can just slap down and say, hey, we did it once, we can do it before. We start at the beginning of the process. We look at our circumstances. Is it different? Is it the same? Have we changed our processes? Have we changed our culture? And then if we, we have to decide if the paradigm has changed, essentially, before we just commit to doing the exact same thing. And in that case, actually, just go back one. So we actually did, a couple of years later, have a scenario with a computer outside of the space station, and the computer had failed, and it helps move big parts of the robotic system. And so again, we needed to go outside and replace the computer and only had about 2 days time to do it. And I was not the flight director, but I got to kind of watch it happen. And it was not to make it sound like they listened to my lecture, but they followed the same process, and it was great to see that they didn't just assume that they could just run it because it was run before. And they were also successful. And they had to do some things differently because times had changed and paradigms had changed a little bit over the years. So I've described HPOs and HROs, and they of course can and do exist independently. You have some organizations that will just rip through performance, and they perform very well, but aren't necessarily very high marks in the reliability side. And then the opposite being true, very reliable organizations, but may not be the fastest or the easiest to turn around an assignment that they might get. And it's very hard to be one of those, and it's very, very hard to be both. And we certainly are not at the top of that unstable equilibrium all the time, and we're always trying to look for how we could be doing better, especially as everything is changing. So just some key takeaways there in the middle. Lead your leader is a key thing, and then making sure you understand where leadership is retained at the management level as well. And then set those expectations, not relying on what's worked before. And then everything that we do is embedded in a lessons learned process, an after action report type process. And it's not just, hey, that went great. What did we do well? Good job, everybody. Or what went wrong? What could we learn and do better next time? It's both, because you not only want to correct what didn't go the way you wanted it to, but also you need to emphasize the things that did go well and really try to make sure those happen again. And this is the same thing will be taken forward in our future eras, keeping our foundations the same: crew safety, vehicle safety, mission success, always looking for ways to improve. And being willing to admit that we need to change our circumstances, our processes, our cultures, always working to try to be the best organization that we can be. And that is it in a nutshell, Ian. I hope I didn't go way too fast. I wanted to try to get through everything in enough time for questions, and there are some links here but it'll be in that PDF that I promised to get to Ian. So I can leave it like this so you don't have to look at my face, or I can go back to the camera.
No, all good. Excellent. I really enjoyed that, Ed. I thought it was I really enjoyed it. It was brilliant. And the visuals at the beginning, I thought were kind of emotional. I don't know, they were amazing to kick off. So folks, I'm sure you've got questions. If you want to ask a question now of Ed, please do so. Just unmute yourselves and ask a question. Everyone must have questions. I can't believe not.
I've got one. Ed, I'm going to jump in.
Go for it.
It's not technical, but it's just about the work with SpaceX and the collaboration between NASA and SpaceX on the rocket program and using a commercial operator for their services. Are you involved in that? What's your thoughts on it, and what does the future look like with that particular partnership?
That's a great question. And I'm involved in it in a few different ways, because the SpaceX is an interesting, and I'm glad you brought it up, because they've been in the business now long enough that they span very proven Dragon cargo vehicles. Like right now we're about ready to undock the 31st cargo Dragon from the space station. They have been flying astronauts to the space station. I think this is the 10th or 11th Crew Dragon that has been up to the space station. So they have shown reliability in that, where, you know, Boeing has started flying crew on their Starliner, but you know, they're in the very early stages of trying to figure out the test flights and getting some cadence going with that. So that's one end of SpaceX's involvement. Their own commercial enterprise, obviously they have the Falcon 9 rocket and then the Falcon Heavy rocket. They're very successful commercially, and using that also to launch humans and cargo to the space station. And so that's kind of one side of it. And then there's this whole other new development side that we're all watching and fascinated with Starship and the Super Heavy booster, and they've got the contract for the first lunar landing. So they're developing Starship's from NASA's perspective, Starship's #1 job is landing humans on the moon. And so we're very invested emotionally, not necessarily financially, in the success of the development of Starship. And then so we've integrated them well into the space station program, and they've been a very good partner. Lots of, as you would imagine, lots of growth and learning between government and SpaceX sides. They took the brunt of having to get a government organization to really turn and help them be commercially viable. But now they are, with us as partners in the lunar exploration piece, and we're cheering them on developing Starship. And then for me personally, the baby behind me here, the first elements of it that we're going to launch is actually going to ride on a Falcon Heavy rocket to get into Earth orbit, and then we'll do electric propulsion to get out to the moon. So I'm a big Falcon Heavy fan right now, but the Falcon 9, yeah. So it's a long answer to your question. Yeah, very involved, and they obviously have unique business practices that there's a lot of opinions about those across the spectrum. But as far as safety, reliability, they've been really good partners with NASA, and partner is a key word. And I hopefully they do well with Starship, and they really help us with the Artemis and getting folks on the moon.
Cool. Folks, questions. Todd, you got a question there, I can see.
I do. I can't help myself, and I've got a million questions actually. So that was amazing. Thank you very much, Ed. I suppose the longevity of the space station's obviously been up there for a very long time now, and I'll come from a reliability point of view. Do you start to see maintenance increase? And I'd be amazed at things like battery life, and how important that would be. But are you starting to see equipment starting to fail, and equipment actually the reliability or maintenance increase?
Yeah, really good questions. And it stems, so the first elements launched in 1998, and the generic requirement is a 15-year lifetime. But the documents don't really specify when the lifetime starts, because obviously they were sitting on the ground for a while before they launched. But no matter how you track it, 15 years has come and gone in spades. So what and really the last few modules were installed in the 2011, 2012 timeframe. So they're even coming up on 15 years. So the lifetime of the space station is going to be driven on the primary structure, and the structural lifetime and the reliability. I don't know the factor of safety value off the top of my head, but obviously you need to have confidence in a factor of safety to be able to sustain the crew. And so initially the space station was everybody agreed 2024, no problem. Life extension was easy. So 2024 became the date. And then from there, they went through an analytical exercise of all the components and all the interfaces to push it out to 2028. And so that all happened. And they are still actually working through the process of everybody certifying that 2030 is a good number, because now you've kind of reached the end of analytical space based on pre-existent models, and so now they're doing sampling. So like the Russian segment is actually some of the oldest hardware, and so now the Russians are regularly, I don't know if it's quarterly or every 6 months, taking a lot of measurements of the structural hull, and then also, like you said, the electrical system. and its capabilities, and then bringing that data down to help inform the models so that they can continue to make the engineering assessments. We also have a lot of strain gauges and accelerometers on the space station to help inform those models as well. So now it's this, I think they're trying to keep 2 to 4 years out in front. And right now, as far as I'm aware, there's nothing that's screaming must end by as far as a date goes. So right now it's in the hands of the politicians. It's a very expensive endeavor. And so when the nations really, it's such an intertwined international endeavor that any one of our partner countries just backs out, that will probably be the end of the program, just because we need all of the pieces. That all said, we're also trying to transition low Earth orbit to be a commercially viable economy. And so I showed pictures, artist renditions of commercial space stations, but that's really our goal. And NASA actually now has a commercial low Earth orbit destination program to help companies develop space stations for low Earth orbit, so those can become the new destinations, so that there's not a gap when the space station program ends. So and then of course NASA as an agency has a very small budget, and so if we get out of International Space Station business, we can take that funding and put it into the next great thing that no commercial company really wants to invest in, the upfront cost with figuring out how to live long-term on or around the moon. And then the goal there is we get an economy going in lunar space, and then we can put our full focus on going out to Mars. So that's kind of the model that NASA is working on. Did that answer your question, Todd?
Yeah, it was great. Thank you very much.
Yeah, you bet.
Ed, we have a question from Matthew at Osnet. Matthew said, how did you define the level of risk that was acceptable to deliver the 36-hour turnaround? What steps did you skip, and what steps were non-negotiable?
Everything associated with crew safety was non-negotiable. So what we did in the very beginning of that 36-hour period is we looked at everything associated with the astronauts and their ability to get in the suits, be safe in the suits, get the suits outside, and then we call it their translation path, but their ability to get from the airlock out to where they needed to work. It's out there by the solar arrays, and there's a massive, literally with mass and then also with size, rotating joints out there. We have to make sure that those are all, the astronauts won't get hit by anything. So we got to make sure the work environment is safe out there. And then also the contingency cases. So the spacesuits are at a 4.3 psi pressure versus standard 14.7 psi inside the cabin. So we have to be able to protect for we'll make sure that they don't get the bends, and that we still can treat that if it does happen. So we have all these medical scenarios we have to protect for. So we did all of that first. And normally that can take up to a week to get all of that in place. So we didn't, because of our circumstances in that particular instance, we were able to go look at every single box on that list and check them off as already complete. We already knew how to do it. If you want to say we were lucky, then that's the case. It worked out that the astronauts we needed happened to be there at the right time in the right place. And another really significant enabler was that the space station program, told us, you're going to go replace this pump, this one pump, because that's probably what's leaking. And if that's not what's leaking, it's going to take way too long to try to figure out what the other problem might be. So you have one job, go replace this pump and then come back inside. So that made it way simpler. We didn't have to choreograph 18 different tasks. And then me as a flight director, I told the entire community that we were not doing anything else, because spacewalks in general are hard to do and it's hard to get outside. And we normally go outside for 6.5 to 7 hours, and this was only going to take us about 4 hours. So it's very predictable for people to come in and say, oh, well, while you're there, how about doing this and how about doing that? And so we very much immediately said, we're not entertaining anything. We'll do this one thing. And if it works, great. If it doesn't work, we're not going to try to repair or fix. We're just going to put the new pump in and come back inside. So those are really the two biggest things that we did. Still went through all of our checklists, but we were able to check almost everything off, either by reusing things we had done in the fall from the previous 6 months ago, or because we had happened to have just done them in the last couple days.
Thanks, Ed. I think we've got time for one more question, folks. If you've got a question for Ed, please shout out now.
Yeah,
Anthony. I was
yeah,
going to
I've
say
got a
Anthony had to, but he's Star Wars. Star Wars is behind you. It had to be
Oh,
you.
that's true. Yes, yes. There we go. All my Star Wars bits and pieces.
Look,
So,
look at that. The Millennium Falcon and everything.
Yeah, confess, space nerd. Sorry, Ed. Fantastic presentation. Obviously, for those of us that have got an interest in this area. I was just looking at one of your slides earlier, the plan, train, fly model that you've got. And I was just wondering, do you use that same model on, I guess, ground-based initiatives or any other type of projects? Can that be applied as well with some, obviously a few tweaks?
I was stalling. I wanted to see if I could pop it up there just so everybody else could see it. Let me share real quick. Can you see it?
Yes, yeah, it's on screen now.
Yeah, okay, great. I would say yes, but I think the challenge will be getting people to want to do it. So it works really well for operations because you're kind of at the tip of the spear, and it's kind of obvious that you have to do all of these things to some extent. Now, we take it to a pretty good depth of detail because of the nature of the business and the lives of the crew. But I think, so in my current role in our program office with Gateway, where we're still in the requirements phase, and we are just kind of transitioning into the early days of doing test and verification. I think my sense so far is that it's been a challenge to get people to be as far ahead looking as this requires you to be, and to think. So, and I think this is one of the reasons they asked me to come in and do the job that I'm doing, kind of integrating all of these pieces together to get us ready to go fly, is because, as I'm sure you all know, you really do need to look several steps down the road to help you understand the pathway to getting there. And you want to think about all the deviations that might happen along that pathway so you're prepared for them. And that very easily fits into this plan, train, fly perspective. You've got your IMS, for example. You look way at the end of it, you're trying to figure out how to get there. That's planning. You're in the process of kind of getting from here to the next stage. That's training, right? And then if you're in your 3-week real close in scrum or whatever, that's the fly component. So I think it is adaptable. I think it's just it would take some effort to get people to have a horizon beyond just what is and this is at least this is the issue that I'm facing right now with my team. Everybody wants to focus on what do I need to do today, what do I need to do tomorrow, and then everything else is kind of like, that's a thing for management to worry about. And so I'm trying to push into my team that I expect them to be thinking about those things, because we're only going to fly a couple years from now if everybody is thinking about flying a couple years from now and not just thinking about the spreadsheet they need to make tomorrow and then they're done. Then they'll just come ask Ed what's next. So I'm trying to do what you're suggesting. And maybe if I see you in July, August, I can give you a better answer on how it's going. But I do think it is doable, yes, and applicable.
Yep. No worries. Thank you very much.
Well, that's a fantastic way to end. I think potentially we've already got Ed coming to Melbourne in July, so he's actually said it. So that's good. Lisa, do you want to? Oh, Rowan. Sorry, go on quickly.
Yes, I finally decided which one of the 10 questions I want to ask.
Okay, cool.
How do you get your staff to jump between that extreme long-term strategic planning, making sure all scenarios are accounted for, into the immediate, we have to make a decision now on the fly, there's an emergency while the crew is up there? How do you get the team? Because in my personal experience, you get people that's really good at long-term and really good at short-term, but to find that combination.
To be honest, I think we have it easier than a lot of organizations because we use the same people to do all three things. So when we're in mission control, that's probably about 30% of our job in a given year. And then the other 70% is spent doing that plan and train component. So we'll spend maybe 50% of the year planning something that's several years down the road. 20% of our time will be in mission control, but training, simulating, doing analysis, preparation, and then that 30% is actually flying the actual real space station. And so I think it's from that perspective, it's easier on the operations team because we do it. We don't have separate teams that do each of those functions. We just have all one big group of people that spread across all three functions. And I would think, yeah, obviously you can do it differently, but then I think that's how you run into, I think the question you're actually talking about, you get kind of siloed one between the other, and then trying to have the data feed the communication between and the experience base, right? People that, so an advantage is that somebody that designed a mission a couple of years ago can be the same person that then goes and actually does it in real time. And so they carry with them that knowledge, just like when you have an engineer that did the design or did the analysis, then they are in the operations environment, then they it's harder because you have to train them to be good engineers and to be good operators. But the benefit, if you're successful, is that they have in-depth knowledge about that particular component or system that they are able to bring with them. Like either way, it's a challenge, I think.
Thank you. And I think that simulation piece is absolutely key.
And we spend very little time, like I mentioned before, we spend very little time focusing on simulating that first failure. We spend a lot more time either just failing a bunch of different things that in the end, because the training team is sneaky, makes it really stressful and complex for the team to put them in that same stressful environment they'll be under, on a real day if we have a bad day, or just flat out put them into those multiple failure scenarios that they have to work through.
Any more questions, folks? We've got 3 more minutes. Told you there'd be a lot of questions, Ed. We did say
Yeah,
it.
I love it. I love talking. I love talking about it.
Fantastic. Okay, well, I love that. It was brilliant. Thank you, Ed, for your energy and all of that information. It was brilliant. Yeah, and as I said, I thought it was really emotional at the beginning. So it was the whole thing excellent. Folks, if you haven't already joined the mainstream community, please do that. There was a link I put in the chat earlier on. Lisa, do you want to see us to close?
Ed, thank you so much. We're running these monthly masterclasses, and this one was just tops. Like, you really, what a session. Everybody kept commenting, never seen that before. Just constant stream of appreciation and enjoyment as well. And not only is your content fantastic, but you're also a very natural presenter, like very calm and natural and pro, and a lovely person as well. So you definitely, I heard you say maybe it is definite to mainstream Melbourne. So you better put it in your diary, Ed, 28th, 29th of July in Melbourne. We're not letting you get away. It was 2016 the last time we had Ed, so well overdue. And Todd, I see you there, who's on our Mainstream Advisory for Mainstream Summit in Perth in March. So I don't know, Ed, it's the 6th of March if you're available. We'll have to get into the next summit round, Todd, the next year round. So we're going to be after you now, Ed. We have to just fly you fast somehow to each place. But beautiful content, thought-provoking. That video was extremely moving, made us realize what a little dot we are on the earth, and also how this big earth is out there to go and discover and be in our world. But what a beautiful community this is in our part of the world. There are very special people on this call or in this session from the mainstream community, and those new as well. Welcome. There are many more masterclasses. There's one a month, and when you come into that online community, you will get those masterclasses as well as podcasts and white papers and the chance to stay connected to each other. So it's very important, the connection that mainstream stands for and the quality content. So Ed, you fit the bill. I mean, you exceeded all expectations, and a huge thank you. And I know Ian will be in touch to lock you in as a keynote for Mainstream Melbourne. So thank you. Thank you, everybody, for being here.
It's my pleasure, my honor to talk with you. Thank you so much.
Have a good weekend.
Thanks a lot. Thanks, Ed.
Everybody.
Thanks, folks. Thanks, Ed.
Cheers.